Good afternoon. Many thanks, Anu, for the nice and kind introduction. So today, in next 45 minutes or so, we are going to discuss about the analytical requirements, which are becoming very, very important for national as well as international trade. So when you talk about residue analysis is very challenging task, because residues are always present at a very, very low concentration, and there are numerous things in any plant or animal matrix which gets co-extracted when you try to extract something by any solvent. So first challenge is that concentration is too low. It's always below ppm. Whenever you apply pesticides, these days the pesticides are applied as such in terms of grams per hectare. Earlier, once upon a time, like in the era of organophosphates or chlorinated hydrocarbons, people used to apply in terms of kilogram per hectare. So now application rate is so small that when residue is actually estimated in any commodity, for example any pesticide in any fruits or vegetables, then naturally residue concentration will also be very, very less, and usually not above 1 ppm or so, even on the day of application. So when you harvest a material, naturally residue concentration becomes almost close to ppb. So question is how to analyze those pesticides with correct interpretation, with high precision, high accuracy, because this is a regulatory kind of analysis. Based on the analysis results, it is decided that whether the material or consignment is fit for consumption, whether it is fit for export, whether it is fit for release into the domestic market. So all these points are based on the analytical test result. So when you talk about matrices, whether it is a plant matrix or animal matrix, there is a huge difference, huge diversity. It can be a high sugar material, low sugar material, high fat, low fat, and high to low water contents. So when you speak to any nutritional chemist, they will say that they are only bothered about protein, carbohydrate, fat contents of the material or nutritional element content. But when you ask a residue chemist, which is the most important or one most important criteria for a matrix to test, then everyone will agree that moisture content probably could be the one of the most important criteria. If the material has lot of moisture, it's very easy to homogenize. It is very easy to extract. If it is very dry material, for example a seed or soil, such type of material which does not contain much amount of water, so always it is said that you soak it in water first. So when you soak in water, it starts releasing the things in the matrix, and then it is easier to homogenize. So just like a kitchen practice, we don't homogenize anything without adding water when you homogenize spice or anything which does not contain much moisture. So depending on these physicochemical properties or nature of matrix, the analytical method is also devised, analytical method is also modified. And of course, when you talk about the properties of pesticides or veterinary drugs or antibiotics, any compound, basically they may be highly water soluble to very less water soluble. So depending on that, in a multi-residue situation, it is not possible to have recovery of everything at the same level. So that's the reason, if you look at any validation guideline, they always say that acceptable recovery range is between 70 to 120%. Why? Because when you try to analyze a mixture of 100 pesticides or 200 pesticides or even 10 pesticides, each pesticide has a different solubility. Each pesticide has a different chemical structure, and that chemical structure governs whether it is more lipophilic or more hydrophilic. So when you try to analyze or try to extract something with ethyl acetate, for example, then more lipophilic material, which is ethyl acetate is an ester, and fats are also like esters, so they like each other. So their extraction will be facilitated. When you try to extract something by acetone, it loves water. So naturally aqueous matrices and whichever pesticide has more water solubility, they get extracted in a better way. So physicochemical property is something which largely governs the accuracy or recovery of a compound when you try to analyze in any matrix. And that's the reason your analytical method cannot have same accuracy level for all compounds. It has to be in a range. So some compound is highly represented. For example, they achieve recovery close to 100%. And many compounds we cannot achieve 100% extractability. It will be somewhere 70-75%. And at that time, we always say that, okay, let it be a less recovery, but it should be highly precise. When you analyze a sample in multiple replicates, the result should be very close to each other. So, for example, if it is analyzed in 6 replicates, the result should be within plus minus 20% of relative standard deviation. So, such type of criteria has been mentioned in analytical methods. Then, when you talk about expectations, what our clients expect, what the food industry stakeholders expect, they expect high throughput analysis. So once a sample is submitted to a laboratory, they want the sample to be analyzed within maximum 1 or 2 days. And analysis has to be done for as many number of chemicals as possible at a very low level, preferably at below 10 ppb, and it should be as cheap as possible. So balance between performance, cost and speed of analysis. This is very important, which is very difficult to achieve, but we don't have any possibility to escape. So this is something, residue analysis is something which is different from nutritional analysis. Residue analysis is a highly regulated analysis. You may be a very good analytical chemist, but if you do not achieve your analytical results as per the quality compliance criteria, as per the food safety criteria, trade regulatory criteria, then your result is not acceptable. So when you talk about our domestic sector, FSSAI regulation is there, we have our Indian MRLs. So analytical method has to comply with the MRLs, that is the minimum requirement. And when you analyze a sample or monitor residues for export purpose, then it's very important that we should know what is the requirement for those importing countries. So their MRL could be very low. So our analytical method should be able to achieve a sensitivity level and accuracy precision level at that low level. That's a minimum requirement. And various countries have various kinds of standards. European Union has probably the most stringent standard, and nowadays in most other countries they are also adopting similar kinds of standards. Even in the FSSAI scientific panel on methods of sampling and analysis, where I participate, we also talk about harmonizing our standard with the global standard. So how to harmonize? European Union standards are the most comprehensive. They have maximum number of MRLs probably available with so much commodity contaminant combination. So naturally we should look at that what is the European value, and our MRL should not be too much different, because then what happens, there is a high level of diversity. So some material comply with Indian regulation and does not comply with them, and there are various questions arises that whether the material which is safe for European community, whichever level is safe for them, why not same level should be applicable for Indian community also for our domestic consumption, because we are also exposed to pesticide. We also don't like pesticide to be deposited in our body. So why so much diversity? Why different countries have different standards? Because food safety concerns are different in different countries. There are differences in how food is grown, prepared and consumed across different countries. And when you look at India, India itself is a representation of the globe, that you go from east to west, north to south, food style of taking food, the composition of daily food is so different. Although codex standards are generally acceptable across the world officially, but individual countries are allowed to have their own standards. So individual countries, they may have their own MRLs, because there are variations in risk incidences because of different kinds of food habit and various other factors. And naturally method sensitivity requirement has to comply with that country's requirement. So why chemical residue monitoring is becoming increasingly more and more prominent in Asian countries? Because India is one of the hotspots of MRL non-compliances. So this is a kind of world map which created by European Food Safety Authority. So darker is the color, more number of non-compliances. So you see that India is one of the darkest color region from where lots of non-compliances are reported for various reasons. And not only India, our neighbors like China, Thailand, etc., they are also equally contributing to lots of non-compliances for various reasons. So overall, continent-wise, maximum number of non-compliances are reported from Asian countries only, followed by Europe itself. So it's not like that European countries produce very safe food. So they also have lots of non-compliance issues. And these are various reasons why a food consignment could not get entry into European market. This is the classification of European Food Safety Authority's report, that there could be several reasons, not only pesticide. There could be almost 27 different reasons because of which the food material was not allowed for human consumption. And if you take a closer look, you will see that pathogenic microorganisms like Salmonella, E. coli, these are probably the most prominent thing because of which our consignments are getting rejected. Lots of Salmonella issue in betel leaf and various other things. And when you talk about chemical contaminants, major contributors are pesticides, mycotoxins. You know that aflatoxin is a big issue always. And certain other things are almost very similar to contribute, like heavy metals, etc. And commodity-wise, if you look at that, non-compliances regarding various chemical residues, maximum number of non-compliances are reported for fruits and vegetables, because fresh fruits and vegetables, what happens, these are freshly harvested, and many cases they do not get regulated pesticide applications. If you look at our Central Insecticide Board and Registration Committee's website, not many chemicals are registered for usage in many of the crops. So farmers do not have adequate choice when there is an insect attack or attack of any fungal disease. So what happens, whichever chemical is available in the local market, they try to apply. And so there is a concept called good agriculture practice. Good agriculture practice promote safe use of pesticide. And when you talk about safe use of pesticide, you mean that once a pesticide is applied through proper process at appropriate dose, appropriate point of time, then at the stage of harvest, its residues should not be detected above MRL. So that is the main concept. But such type of information, that what is the residue dynamics, how fast a pesticide breaks in a commodity, those types of information are in many cases they are not available for a particular pesticide and crop combination, especially in case of vegetables. So that's the reasons good agriculture practice information is not available, so lots of detection issues. Then next category is fish and fish products, and after that this nuts and nut products and various other commodities. So that's the reason when you devise a residue monitoring program, it's always a big challenge that which chemical to monitor. So for example, when we started monitoring pesticides in Indian grapes, which became a big problem in 2003, almost 17 rapid alerts were there for Indian grapes in 2003. So then a residue monitoring program was initiated. So then question came that which pesticide we should monitor. So first people said that, okay, whichever chemical farmers are applying. Now which chemical farmer is applying? How to know that? Farmer can apply probably any chemical, whichever is available in the market. So initially we looked at that, what are the pesticides which are having official endorsement as per our Ministry of Agriculture, that which are the chemicals are allowed for application in grapes. So those have to be applied. Those have to be tested. But then you come to know that there are adjoining crop fields, so people are applying many other pesticides. So finally you come to know that probably you need to test almost all the chemicals which are available in for use in agriculture. So because those pesticides may appear from the indirect sources, from adjoining crop fields, from various contaminated agro inputs or fertilizers, manures, these are not free from pesticides. So sometimes they also come as a source of contamination. So mainly in agriculture crops, pesticide residue is the most important thing, but there are product specific requirements, sometimes mycotoxins, antibiotics, rub residues, and persistent organic pollutants are also coming as an emerging contamination issue. So in whichever is the case, when you try to do a comprehensive residue analysis, best idea is go for multi-residue analysis, because otherwise for a list of pesticides which runs into hundreds, then how many days you can contribute to analyze that. So once before 2004, when we used to analyze samples for a set of 50-60 pesticides, it used to take almost 1 week, because there was chemical class-wise analysis. But then people started combining various chemical classes. So just to let you know the history of multi-residue analysis of pesticides. Pesticides used to be tested earlier as a single compound. So you have a method for DDT, you have a method for VHC, like that. So before 1960s, this TLC, paper chromatography, those used to be the method. In 1960, the first awareness came because of publication of a book called Silent Spring by Rachel Carson, who informed the global readers about the poisoning issues, toxicity issues of DDT. And then people started developing a method for chlorinated hydrocarbons, because those days DDT, aldrin, heptachlorochlorine, endosulfan, those were the main compounds to be tested in any of the commodities. Then gradually the method was further developed, and most of the developments were in under the tutelage of this US Food and Drug Administration, because they were very proactive in that. And finally in 2003, Quecher's method came, and this method probably revolutionized the entire process of residue testing. So if you look at the older methods, lots of steps, various steps. You take a sample, and those samples used to be in say 50 grams or 100 grams, then extract it with solvent, and that too extraction used to be in at least 3 times. So extraction, then you do a partitioning step, so many steps, and after that finally you used to get the final extract to inject into instrument. And at that time there used to be only gas chromatograph. That was the only instrument people used to use with electron capture detection, or sometimes flame photometric detector. So after that this loop method came, because in this earlier method what happened, here this method was not so good for relatively polar pesticides. This was quite good for chlorinated hydrocarbons like DDT, aldrin, heptachlor, and that entire group, because those compounds are highly lipophilic, and here extraction solvent was acetonitrile, and this method was predominantly validated for fresh commodities, non-fatty foods. But then lots of organophosphates were coming into the international market, and so and this method was not giving good recovery. So then they replaced this acetonitrile with acetone, and this gave much better result, and this method is still in existence in various laboratories in the form of a mini loop method. So main problem with all these methods is lots of steps, and finally at the end of the thing you sometimes, because of certain error, you don't get repeatable result, and it does not give well justified result for a big list of chemicals, because for some chemical it is giving very good result, and many chemicals it does not give good result, and lots of moisture issue, because acetone extracts almost everything from a matrix. So there was hardly any selectivity. So then people started replacing it with various other solvent combinations like ethyl acetate, combination of ethyl acetate with cyclohexane, such kinds of solvents, and various other techniques like accelerated solvent extraction, supercritical fluid extraction. So various technologies people started applying, but each and every method had certain flaws, because these methods did not provide good result for a multi-residue situation. Those were all very good for chemical class-wise analysis. So finally in 2003, this Michelangelo Anastasiades He was a postdoc with Stephen Lehote in US DA laboratory, and they developed this method as the first large-scale multi-residue technique. And if you look at this method, first it will be so intriguing that whoever is using HPLC, we know that acetonitrile and water is a very good combination, and they tried to separate this acetonitrile and water. Normally, if you add acetonitrile to water, this mixes so well. And here we talk that you extract it with acetonitrile, then it gets partitioned, and instead of taking it from below, you pipette it out from the top. I think Quecher's method is already explained. So this is something very intriguing, that they thought that something which is highly miscible, how to separate it out. So lots of thought process, lots of ideas, and then they came to understand that a combination of 4 gram magnesium sulfate and 1 gram sodium chloride, if you add, then acetonitrile starts getting separated from water. And wonderful thing is that acetonitrile forms the upper phase. Earlier, all such type of liquid-liquid partitioning were based on dichloromethane and water. So dichloromethane used to form the lower phase. So people used to use a separating funnel, and from below that they used to take it out. But here, big advantage is that it was on the top, and in the same time, many of the big instrument vendors, they started bringing high quality mass spectrometers, which were very good in quantitative analysis. So here it's a balance. You are not analyzing a sample in a very exhaustive way. It's a single step analysis, single step extraction. So your extract is very dirty. It's not clean at all. You can see that lots of efforts are going, and every effort is basically to clean the material more and more clean, remove all the co-extractives, bring out the pesticide selectively in a solvent, and that is injected. So many of the co-extractives are removed, but it's a very shortcut method. You just do something, and there is a picture that Steve Lehote mentions, that you take 4 tubes here, 4 tubes here, and just like in a gym, you do this type of extraction, which received lots of criticism later, because this depends that if you are too strong, your shaking is very good. If you are weak, your shaking is not so good. And if you are unmindful, your shaking is too bad, and recovery will vary. So then people started telling that, no, don't promote this way. You say that there should be a homogenization step. Use a homogenizer, proper homogenizer, or even a vortex mixer. You mention that how much time or what speed has to be used. So otherwise, person to person variation was too much. So then this 2003 method became a champion method. It was published in Journal of AOSC International, and it attracted lots of attention. In one story, we came to know that this loop method, which this gentleman, loop was from also US FDA, and this method is from USDA basically, and they don't get along each other. They almost, it's a cold war. So when this method came up, this gentleman, Dr. Luke, said it's not possible. It's impossible, that a method cannot be so simple. So why this method became so simple? Because it got support of triple quads. It got support of MSMS technology. Otherwise, it's a jungle of pit. It's an ocean of signals if you inject such type of extract in any non-selective detector, and then you have to search where is your compound. So then this method got lots of versions. Every laboratory in the world has a modified Quecher's method, and including us. So Quecher's method has become a philosophy kind of thing. So you apply this idea and modify it a bit, and then show its performance as per the performance criteria. So that is the basic idea. So there were lots of modifications, and in 2007 it got endorsement as the AOSC official method. So it is AOSC 2007.01. It became a global, there was a global collaborative study through which they came out this 2007 method. So what are the perspectives and expectations? So if you look at pesticide analysis, almost 400 plus pesticides have emerged in European Union. And if you look at consolidated list of pesticides across the world, like Codex EU, Japan has a very long list, 800 plus pesticide emeralds are there. So approximately it is said that 600 to 700 chemicals probably available in agriculture across the world. So usually our exporters say that why don't you analyze each and every compound so that they can take a decision that which market is the best market to export. Because something may not fit for Europe, but it may fit for export to another country. So this is the main idea of this, and when you go for such type of analysis, there are three possibilities. If you have reference standard in your laboratory, then you can go for reliable target-oriented analysis. That means you can detect the compound and you can also quantify the compound. You have the reference standard, so you can develop a calibration line, and through that you can estimate the concentration. If you do not have the reference standard, there is a possibility that you can still mention that whether it is present or absent, because mass spectrometric analysis supports that on the basis of certain unique mass, you can say that with certain level of confidence that this compound is most probably present in a sample. And finally, screen for unknowns. I think Rajesh will tell something maybe in his talk that nowadays people are talking a lot about high resolution mass spec applications, because I think India is a typical country for non-targeted screening. We really do not know which chemical a farmer has applied. So we were discussing about chlormequat issue. You know that chlormequat is a growth retardant. In 2010 there were almost 13 rapid alerts for Indian grapes. So question came that how many of the Indian grape growers applied chlormequat? So there are big questions. First, as for anything, any problem, government bodies are criticized. So they first asked us that why chlormequat was not included in the monitoring program. So we said it's not a pesticide, it's a plant growth hormone, and plant growth hormones are apparently innocuous substances. So no one in the world monitors them. So then next question is that, but we apply it. So APIDA said that okay, let us do a survey that out of 17,000 farmers who registered for export in that year, how many farmers in their spray record mentioned that chlormequat was applied. Surprisingly, around 3% of the spray records had been mentioned. The rest of the people said that we know that good agricultural practice certification says whichever you mention and whichever you apply, they should tally. So since and means whichever chemical you apply, whichever chemical you mention in the spray record, those should be equal to the whichever chemical you test for final compliance. So these three figures should be same. So whichever is not tested or whichever is not as per their spray record, they don't mention in the spray record. And same is the case in 2016 also, when we were talking about this one, our GAP Good Agricultural Practice Review for chlormequat, we came to know that there are hardly any mention in the spray record. So you really cannot rely on such type of things. So screening for unknowns really become a big possibility in Indian context. So sometimes we say that lots of cow dung manures are applied, lots of poultry manures are applied, and who knows and who tests Indian fruits and vegetables for veterinary drugs? No one tests. If someone tests, probably they will find something. Because there are possibilities, because indirect source of entry of residues. If you look at these residues of persistent organic pollutants, various reports are there that they are coming from indirect possibilities. So in AOSC India section conference, there was a mention in one presentation by Professor Glenn Kennedy from European Reference Lab in Belfast. He mentioned that horse dung was used as a manure for in a field. Grass was grown in that. Cow was there to feed on that grass, and those compounds appeared in cow milk. So what was a very complicated route of appearance of residue. And that compound which was applied in horse, means horse was treated with that drug, that was a very, very low concentration. But you know that there is a concept called bioaccumulation. So compounds get accumulated in the body system, and if the body has lots of fatty tissues, those compounds get deposited there, and this finally eventually comes to the excreta, and finally it enters into the ecological chain. So depending on this, that whether you want a targeted analysis or untargeted analysis, and whichever big list you have, analytical method could be of two types. One could be like a generic method. So you say that quantitative screening of agrochemical residues in fruits and vegetables, like a method, this type of titles you will find, where you mention about analytical method, which should be applicable for a huge number of chemicals. Methods are available even for 500, 600 pesticides, combination of pesticide, drugs, mycotoxins, etc. Various literature is available this way. And here main idea is that you try to extract as many chemicals as possible. And in the lower side, lower panel, you see certain selective methods. So method could be selective, class-wise selective, and method could be very generic. And generic method, one problem is that generic methods cannot take up all the chemicals, because there are certain chemicals which cannot be extracted by regular methods. So they require certain special treatment. So you have to analyze those things with separate ideas, separate procedures. So that's the reason if you look at European system, European Union has a separate reference laboratory on single residue methods. So there are chemicals like glyphosate, chemicals like ethefone, dithiocarbamate, even certain antibiotics like casugamycin, tetracyclines. So those compounds, they require special treatment, special kind of workflow. So they are analyzed as a separate method. So finally, identification of analytes and confirming the results. The two things, one is chromatography, because chromatography has to be done, otherwise compounds cannot be separated. And however fast is your analytical technique, like whichever is the speed of your mass spectrometry, there should be some separation is required. Otherwise, if too many compounds at a time they reach the mass spec ion source, there will be certain, always there will be certain problem. And mass spectrometric identification here, if you look at any regulation, they always tell one thing, that when you talk about mass spectrometric analysis, it should be analyzed based on the characteristic mass spectral information. So every molecule has a characteristic mass spectra. So there are certain masses which are very selective for that molecule. So you should qualify that these are the specific masses selective for the molecule. And based on that, you have to justify your identification. And so that's the reason when we ask for data from any laboratory, we say that please don't send total ion chromatogram. We need extracted ion chromatogram, because extracted ion chromatogram extracts the selective information of the particular molecule. Then only you can look at, because otherwise a TIC just look like very dull. It doesn't show the individual signals so well. So this is a screenshot of the Sante guideline. This Sante is basically their Ministry of Health in Europe, and they mention that nowadays selective detectors for GC, for example, ECD, FPD, PFPD, NPD, and ILSI, for example, this diagonal detection or fluorescence detections are less widely used, as they offer only limited specificity. Their use, even in combination with different polarity columns, does not provide unambiguous identification. So there will be a sort of ambiguity that which chemical it is. Are you sure that you are reporting a pesticide, reporting any compound? How sure you are that this is 100% correct detection? And so based on that, there are two approaches. One is tandem mass spectrometry or MSMS. You must be aware of that. So every molecule is basically ionized first. That is the first and foremost criteria. Then when it reaches to a collision cell, it is collided and then develop characteristic fragment ion. And this unique combination of parent and fragment ion gives identification of a particular compound. And another is the accurate mass measurement, which has various techniques like mainly Q-top and orbit trap are the most important techniques which are available for quantitative residue analysis, because here we are only talking about quantitative analysis. Otherwise, in old generation system, mass spectrometry means looking at molecular structure and all the things. Here it is more or less information dependent analysis. We have some ideas, we have some information. So based on that we are analyzing. It's not like looking at a mass spectra and trying to elucidate the structure of a chemical. So those days are gone. Now here it is much more information dependent, and softwares are also having so many features which helps you in deducing that which is the probable chemical residue for which you got a signal. So in general, for targeted analysis you require a triple quad system. Ion trap is no longer available in the world, and single quads are more or less not used at all in quantitative residue analysis. They are still in existence for certain selective analysis. And when you talk about screening, which could be qualitative and to some extent quantitative, and these days very good quantitative sensitivity is achievable by these high resolution systems. So it is either GC HNMS or LC HNMS. So why MSMS is so important? Because when you talk about analyzing say 100 pesticides, you really cannot chromatographically separate all the compounds. If you want to chromatographically separate 100 compounds, your runtime will be too long, and sometimes various compounds may have such a close similarity in terms of their physicochemical properties that their retention time is almost the same. So for example here, these two compounds, their RT is the same. So if both the compounds are there, and if you are using a regular electron capture detector or such type of non-specific detector, you get a single signal, and that signal will combine actually two compounds. So this will neither reflect the first compound or the second compound. Similarly, this cyperazine, desmetrin, dimethachlor or pretylachlor, 2,4-DDT oxidazone, various different types of compounds. One compound could be extremely toxic, another compound is not that toxic. So the question is that if you detect 2,4-DDT, which is a brother of DDT, then there is a huge problem. Dr. Anup Krishnan will visit your laboratory and raise so many big questions that why it happened. So first question I remember that in one European pesticide residue workshop, one gentleman from Bangladesh, he presented that they detected certain chlorinated hydrocarbons in some fish samples. So there are so many questions that how it is possible that still you are detecting aldrin, heptachlor, chlorine, etc. Then we came to understand that although they analyzed the GCMS, but they used a single quad instrument, and they used only one ion to identify that compound. And that ion, if you look at NIST library, thousands of compounds may produce the same M by Z. So confirmatory criteria has not been applied. So since confirmatory criteria was not applied, and we chemists become very excited that something has been detected. I remember one of our juniors from Indian Agriculture Research Institute, she joined this Center for Science and Environment sometimes in 2004-05, and her boss told that we should create some sensation in the market. So she immediately did that, identified some chlorinated hydrocarbon compounds in Coke and Pepsi, and that created so history. And finally they could not justify that on what basis you say that these compounds are present. Then there were lots of cartoons that the farmer is applying Coke and Pepsi to control pest. But yeah, in the knapsack sprayer on the backpack they were spraying Coke. But those are all cartoons, and finally the AOSC came into the picture that okay, you justify that why you are saying that DDT has been detected in Coke. That could not be justified, because if you talk about identifying a compound on the basis of a single compound, it's just like identifying myself based on my nose. If it is very characteristic nose like this, some bend, etc., still there is a possibility, but usually it's not a very specific character. So in this MSMS also, initially people thought that it's almost a solution for everything, and it is also to a large extent. You see that because of that deconvolution possibility, software identifies each compound in a different color, and so multiple compounds, they are identified based on their unique parent and daughter mass combination. So that's the reason whichever number of chemicals are coeluting, it is possible to quantify them separately. And based on this, there are several software. If you look at any instrument vendor, there are possibilities of automation of these MRM methods. So what they say that you run that mixture of compounds, you identify the parent ion and best combination of the parent and daughter ion, and which collision energy provides the best possible response. So this way you come to such type of database, that list of the compounds, their start time, end time, and various combinations. So these analytical quality control guidelines, if you look at, this is the most comprehensive guideline, guidance document on analytical quality control and method validation procedures, which was came into existence on 1st January 2016 this year. And there is another document which is created by US FDA, which is very similar to this earlier Sante method also. And here also they talk about method validation guidelines, which is largely a component of the Codex General Manual. And these methods, they categorically mention each and everything, starting from sampling to final measurement of uncertainty. So sampling means how much sample to be drawn for which commodity. So if it is a pre-harvest sample, what should be your possibility, what should be the method of sampling, and how much, if it is a fruits, vegetables, how much fruits, how much vegetables. If it is sampling for milk, how much minimum milk sample has to be brought. So such type of information is available. And when you talk about analytical method, starting from preparation of standard solution until final analysis, each and every component is very well covered. So these are the major things. First thing is that sensitivity or linearity. So minimum check requirement is 5 levels of linearity check, and if it is more than that, 6 levels is further good. So what you do here, you get such type of linear graph. So when you look at any linear graph, you see that each and every point are not on the straight line, because straight line is something which is a trained line they draw across all these points. And here there is a definition that this difference of this point from the straight line, that deviation should not be more than 20%. That should be within 20%. So this is very important. Otherwise, you need to probably recheck the linearity. So here in linearity, there are certain things. If you study this Sante guideline, first thing is that you, under such situation, you redo the calibration, and still this problem, then you try to squeeze it, that instead of going to such a high level, you try to squeeze into within a shorter dynamic range. And if that also doesn't work, then probably apply a different equation. So there are multiple equation possibilities, not only straight line, it could be a quadratic line and all the things. So final, our idea is that we should get the most accurate result for a sample. Second thing is the matrix effect. So when you analyze anything, any organic contaminant in plant or animal matrix, huge matrix effect problem comes, especially those compounds which are present at a very low level, and your matrix is very complicated. For example, when you analyze spice, any spice sample, cardamom, chili powder, all these things, they produce huge matrix, because when you extract something, extract your compound, along with the compound, lots of pigments they come, lots of fatty materials they get co-extracted, and everything reaches your ion source. So major reason of matrix effect, major place where matrix effect occurs is not in the mass spectrometer, not in the triple quad system. It actually happens in your ion source, because ion source is the place where your compound and all the matrix compounds, they reach together. And then if there are too many additional compounds along with your target compound, then what happens? Your target compound does not get enough opportunity to get ionized. And your additional compounds, for example, lots of polyphenols, plant pigments, fatty acids, these get co-extracted. And they have functional groups which are easy to ionize. They have lots of OH groups, lots of NH groups, NH2 groups. So they have these free electrons and they get easily ionized, and because of that what happens? Ionization suppression happens. So under such situation what happens? If you look at this case, it's not so clear. So here we analyzed glyphosate. So glyphosate, if you analyze, sometimes the signal is so suppressed that your recovery, if you calculate with your solvent standard, it is not more than 60% or not more than 50%. So under such situation, one possibility is that you analyze with internal standard. So internal standard is something which normalizes the recovery loss, and then you get recovery of almost close to 100%. Then next important is that limit of quantification. So LOD and LOQ, these are the two important things, and you should know that limit of detection is basically an instrument parameter. So you try to get as low as possible, and here for example, we need to know what is the noise level and what is the signal level. So all over the world, although there are too much of statistics people talks about, but across the world, people, what they do, they try to calculate the noise and what is the signal intensity, and this is the lowest level in a solvent standard, pure solvent standard of course. Your signal to noise should be at least 3:1. That is the minimum requirement. And when you talk about limit of quantification, there are a lot more things. First point is that signal to noise should be at least 10:1. But along with that, you should remember one thing, that limit of quantification is something which has straightaway relation to your analytical method. So the entire process is related to this limit of quantification. It is not only the instrument detection limit, it is the complete method performance evaluator. So what happens here, for example, if you look at this calibration line, it's a pretty good calibration. But you need to zoom this lower part, because lower part is something where response is not so good. If you look at all the peak shapes in the lower concentration levels, peak shapes are never so good. There could be little bit tailing, a peak may not be so sharp, all these issues come up. So at this lowest calibration level, you should look at what is the shape of the signal and what is the signal to noise ratios. For example, here S by N is almost close to 10, and that's the reason you could say that this is by LOQ. But here another important point is that what is the performance of the method at that level. So traditionally what people do, people does extraction of a blank matrix, and in that blank matrix extract they spike. It's a post extraction spike, and then they check what is the signal to noise ratio. So this is one thing, but as per any official purpose, it's very important that we should have appropriate recovery and precision at this level. So for example, if you look at here, we got limit of quantification 1 nanogram per gram. At that particular level, when you do recovery test, you get recovery of around 98%. So this is very important, that your recovery should be within the acceptable range at that level. If its recovery is too low, below 70%, and it's too variable, relative standard deviation is too big, then that cannot be your limit of quantification, because sometimes it happens that one time it comes very good, but it's not repeatable. So if it is not repeatable, then you cannot say that this is my limit of quantification. So there could be multiple ways by which you can improve your LOQ, cleaning the system, you improve your extractability, sometimes you concentrate the extract, and if you have a very highly sensitive instrument, it's sometimes possible that you dilute the extract and shoot, because dilution reduces matrix. So this is very important, that at limit of quantification your signal should be at least 10 times higher than the noise, and at that level your recovery should be within 70 to 120%. And when the this spiked sample is extracted at least in 6 replicates, your relative standard deviation should be below 20%. So these are the certain things. So here is a very good result, like 98% recovery with 8.5% relative standard deviation. So this type of information is very important, which justifies that your result is accurate or not. So whenever any rapid alert or whenever any issue comes up, question comes that whether the lab test was correctly done, whether the lab had appropriately validated method or not. So these are the certain things which justifies the result to a great extent, that see, my laboratory has validated the method with so much proficiency. Then there are certain identification requirements which you need to look at. So when you analyze anything by MSMS or tandem mass spectrometry, at least 2 ions we should look at. So it could be one parent with 2 daughters or 2 parent-daughter combinations. So this is very important, otherwise it is not acceptable. And when you analyze any compound based on these 2 transitions, their the peak area will be different. It cannot be the same. So where you get more sensitivity, you use that for the quantification purpose. And the other one, which has relatively less sensitivity or less peak area, that is used for confirmation or qualitative identification. So these 2 peak areas, you calculate the ratio, and that ratio is used for confirmatory identification of the compound. So this is very important, that each and every compound should be tested based on 2 parent-daughter combinations, and their ion ratio should not vary by more than 30%. Vary means what? So you have ion ratio in your standard versus ion ratio in your sample. So when you analyze a sample of vegetable, for example, you check what ion ratio you get, and if that ion ratio is matching with the ion ratio of the standard, then it is accepted, otherwise it is not accepted. And these ratios cannot be the same. So there is a range, it is mentioned, that plus minus 30% is the range. So for example, why 2 transitions? So these 2 compounds, azinphos methyl and phosphate, both has same parent-daughter combination. 318 is the molecular mass, it produces 160. They are also 318 to 160. So question is that which compound it is, and retention time is so close, 5.95, 5.92. So under such situation, if you look at the second transition, this one 318 to 132, which we get by injecting the standard compound, you don't see it here in this sample. But 318 to 77, which is a characteristic qualifier ion transition for phosphate, that is detected. So here it is clearly mentioned that this compound has to be phosphate and it is not azinphos methyl. So these are the ways by which you nullify the possibilities of false detection. Here one example, there is a mistake, it should be false positive. Just explain that. So here linuron we are analyzing in coriander. So you see that these are the 2 transitions, one quantifier and one qualifier. And when you take the ratio is 1.8. Okay. So then you take a coriander extract. So this is for the standard in solution. Now take an extract of coriander, and you find that there is both the signals available. Both the signals of linuron are present. But if you calculate the ion ratio, it is 2.4. So now you need to check that 2.4 is within plus minus 30% of 1.8 or not. If it is not, then it's a false signal. So these are the certain things we need to look at, because you should not be very excited and report something. Because based on your report, it is decided that whether the material is tradable or not, whether the material is exportable or not, or whether it is possible to release into the domestic market or not. FSSAI is becoming very, very efficient these days, and you know that if such type of non-compliances are reported without appropriate justification, the laboratory may face trouble in future. So next important thing is accuracy. Accuracy means basically what we do by conducting recovery tests. So you add a certain level of concentration, and usually accuracy has to be performed at limit of quantification level. So when you register any pesticide in India, there are typical requirements, like pesticide dissipation study is reported, and analytical method validation is reported. So in that validation, if recovery at limit of quantification is not reported, then results are not acceptable. Because that is the primary thing, that when you say that my limit of quantification is 0.01 milligram per kilogram, I must report recovery at that level. So this is very important, that accuracy has to be tested, and as I mentioned that 100% accuracy is not possible, and when you analyze a mixture of 100 pesticides or 200 compounds, then it is not possible that every compound will be recovered with same proficiency. It's not possible. So that is the reason a big range has been mentioned, that it could be as low as 70%, it could go up to maybe 120%, and sometimes it appears further low. So under that situation, or if it is too high, then internal standard has to be used, because without use of internal standard, those results become highly erroneous. Another important thing is precision, which is very important, that how precise is your analysis, how close are the analytical results. So minimum 6 replicate. These days, if you want to publish any analytical method, if there are less than 6 replicate data, it is not accepted. That's a minimum requirement, they say, that 6 replicate data has to be submitted. And those 6 replicate data, if you do relative standard deviation, usually it is expected that RSD should be less than 20%. So precision, usually two ways people do. One is person to person variation and day to day variation, because you know that in a laboratory there could be 5 people working, and all are not equally same proficient. I find in my laboratory itself, the person who is very, very sincere, their result is also very good. Some person who is not in a good mood, their result is eventually will be bad. Morning time they perform much better, evening time they are in a hurry to go home, their result is not that good. So there are various human factors which probably are included, and those things all contribute to the measurement uncertainty. So precision is something which is very, very important, because if you analyze in 6 replicates and your MRL is 0.01, so sometimes result will be above 0.01, sometimes result will be below 0.01. If the result is above 0.01, regulation says that sample fails. If it is below, then sample passes. So here repeatedly I am telling, your analysis is something which is highly regulated analysis. As per compliance or regulatory compliance, you have to analyze. And second important thing is that based on your analysis, it is decided, lots of economics is involved. So if analysis result is not accurately done, then there is a possibility that ultimately the farmer is going to suffer, exporter is going to suffer, so which we do not want to do. And another important thing is that as a residue analytical chemist, our main objective is that whichever way the sample has come, whichever compound theoretically is present at whatever concentration, we should not do anything to reduce that, to break that. For example, if we want to analyze aflatoxins, you should know that aflatoxin is a photosensitive compound. So it should not be analyzed under bright light, because if you analyze it under bright light, there is a possibility that it itself will break down. So you should not do something which will break the compound itself. So there are adequate requirements that one should look at the physicochemical requirements, physicochemical properties of the compounds. And here you see that what are our requirements. We really do not want too precise or too accurate. We require both the things. It should be highly accurate, it should be highly precise. So this big circle, that is our main objective. So it should be as accurate as possible, and precision level should be quite high. So what can be done when the ion ratio criteria cannot be applied due to low intensity qualifier SNL? That's very important thing, because nowadays in many of the matrices we find that you say it's very easy to say that you look for 2 transitions, but second transition may not be strong enough. So in most of the instruments, in new generation instruments, one good advantage is that you have a possibility of a scan function also. So you analyze it by MSMS, and there is a possibility of doing a full scan. So in full scan, in LCMS you don't get too many fragment ions, but those fragments ions are mostly very characteristic to the molecule, because LCMS is a soft ionization technique. So if these two things can be combined, then there is a more possibility, more confidence on the analytical result. So here you can see that this is such a huge signal, but qualifier ion is a very small signal. So usually it is not accepted. This, if it is such a low thing, then ratio is quite fluctuating. So under such situation, you look at this and also look at this full scan kind of spectrum. Similarly, here there is a signal of this chlorphenapate here also, of both the transitions. So black is one, pink is another one, and both the transitions are present here also. So, but then you look at the full scan. So it perfectly matches with the base kit. This 59 is present here, which is characteristic for the chlorphenapate. But when you look at this one, that 59 is completely absent. So you say that that second small signal does not belong to chlorphenapate. So these are the certain things, some basic chemistry knowledge may be applied, and we should not depend on too much on instrument. Along with the instrument and along with the automations available in the instrument, our human intelligence, our relative knowledge on this chemistry will be very, very important here. So another important thing is that we should not forget about retention time. Retention time is something which usually people have a general tendency that we have a LCMSMS or GCMSMS, and we really do not need to bother about RT. But sometimes what happens, RT could be very close for two co-eluting compounds having similar mass transitions. So under such situation, it's very difficult to say that your analytical result is correct or not. So for example here, it is going. So here this red signal is too big, and small signal is, I think, so the red signal is too big, and small one is here it is integrated, here it is not integrated. It is not integrated, and here it is integrated. So under such situation, it's very difficult to say that which chemical it is. So, but their RT, if you look at, and if there is a possibility of separating them by using a good column, then it becomes very useful. Then finally, if you look at the high resolution systems, which is altogether a big subject, and it's not possible to combine everything in a single lecture. But in high resolution, what you do, you have a possibility of non-targeted screening, and there are very good databases that are available nowadays, and you can develop your own database. So in our laboratory itself, we have developed a database of more than 1200 compounds now, and it's a very fantastic thing that instrument can look at and dig out what are the compounds. It's a kind of mining sort of system. So here you can integrate both MS and MSMS data, and you can do three things. One is quantitative information, that means present or absent, because here you are analyzing based on accurate mass. So accurate mass is very characteristic to a particular molecule. Then you can do quantitative, because if you have the reference standard, you can draw a calibration line, and you can also do discovery kind of thing, which I mentioned about screening for completely unknowns. So this is very important when you talk about identification of any metabolite. So such type of information you get, you analyze a sample, and you get information about its mass, its retention time, characteristic fragment times, then isotopic pattern, which is very important under such situation, that if you have a specific isotope, how they are distributed. Then charge status, all these things. It's a huge gamut of information based on which you can say that this compound is present or absent. And why it was very important, because it is not possible to purchase reference standards, too many reference standards in a laboratory. So when you do not have a reference standard, but still you want to comment that whether a compound is present or not absent, then probably it is very important that you should have lots of subsidiary information. And additional information always are helpful to make it more confidence, to develop more confidence in your analytical result. So finally, what are the expectations from a regulated analytical method? It should be capable of identifying and quantifying all the target compounds at the regulated tolerance limit. That is the minimum requirement. with sufficient precision and accuracy. In general, in case of pesticide, it is said that 0.01 is the minimum level, and in case of banned drugs, you know that MRPL levels are going down and down as the technology is getting evolved. Method should satisfy all the analytical quality control criteria. That's very important. All these quality control guidelines, these are free to download, and I urge all of you that you please read it as a storybook. Just study it. You will really enjoy it, and after a few days, you will try to understand that probably many questions which used to haunt your mind, those are automatically get answered. For example, they clearly specify that you should not weigh anything below 10 milligram. Because if you weigh anything below 10 milligram, lots of uncertainty you are introducing at the beginning stage itself. So there are certain things, if you do it in your own laboratory, sometimes people weigh only 2 milligram of reference standard. So those things are not acceptable in international system. So these are the certain things. So how to prepare your standard solution. So when you use a different solvent, there is a concept of specific gravity. So that's also very important. That 1 milligram is not equal to 1 gram. It is only applicable for water. So you should not forget that while preparing your standard solution. So when you prepare a standard solution in one solvent and you extract with maybe another solvent, and then you try to match, they may not compare. So these are the certain things which are very basic information. So another possibility is that you correct that specific gravity wise information and make it weight corrected standard solutions. So these reduces this uncertainty and measurement fluctuations to a great extent. So how analytical performance can be ensured or improved? We can we should use the appropriate sample preparation technique. We should be very sure that whichever sample preparation technique we are using, that is fit for purpose. Use of high purity reagents, innovative chromatographic sample preparation solutions. Lots of good columns are nowadays available. C18, I am told that more than 200 C18 chemistries are available. If you look at any website of these column chemistries, C18 is not only a 18 carbon chain, there could be lots of branching, and depending on those branching, it may not be always straight. Depending on the branching, their performance improves, and there are lots of substitutions people does, lots of bridging people does. Because of that, their performance improves. So one C18 column may be costing 10,000 rupees, another could be costing 30,000 rupees, because there is a definite difference in their chemistries. And because of that, one C18 column can perfectly separate two compounds. Another C18 columns show correlation. Because of those interactions, they are playing very important role in chromatographic separation. Then highly sensitive and selective instruments. As sensitive instrument you have, your headache is less, because you have a possibility to dilute that material and shoot, and that reduces most of the problems. Skilled human resource is very important. We should not forget that, because ultimately human being is the operator of the instrument, and if he or she is not sure what he or she is doing, finally result is wrongly interpreted, and that creates all troubles. And everything contributes significantly. You have an excellent instrument, but you are using a low purity reagent, then it really doesn't work. So I urge all of you to look at that. What do you mean by LCMS grade reagent? You will find that LCMS grade reagent has very high purity. They are tested for various metallic impurities, because metallic impurities, if they are present in a high concentration, they will produce ions, and those ions also hampers ionization process of your target molecule. So these are very important to look at, that which kind of reagents you are using. Otherwise, your friends from various LCMS, GCMS instrument manufacturers, they will not be useful to you, because solvent will produce so much residues that will be deposited in your ion source, carton plate, on cone, everywhere, and that will reduce your signal intensity substantially. And every alternate day probably you have to clean the machine, otherwise you will not get sufficient sensitivity. So finally, I must say that as food safety professionals, we are facing a mounting challenge to keep up with the scale and scope of the analytical requirement, and these analytical requirements are highly variable, and we are trying to get more or less harmonized through these performance criteria. So you see that these days people talk, they don't talk about any official method. They say that you use your method, but it should qualify or comply with certain performance criteria. That is the most important thing. Food safety standards are not harmonized, and hence analytical methods need to be suitable for the most stringent one with futuristic dimension. We should know that if MRL is going down, then in future it may further go down, and we should be ready with that. And in the absence of harmonization, better national and international collaboration across the community is needed. We should know that we have probable solutions across this community. So if you do not understand, or if you are not able to achieve adequate sensitivity or adequate precision, please ask your friend, please ask your another community stakeholder. Probably we can help in the level of that science. And that's the reason I must say that India section of AOSC International is becoming very active these days, and over the days through your participation we can make a good forum that where barring the thing that you belong to various competitor organizations, but at one level we are all same, we are the analytical chemists, and as analytical chemists probably you can contribute each other's problem solving approach. Thank you very much.
Thank you, sir. Now I would request very fast. You have to make it fast.
Whether NRL can produce some reference material, because just in my session there was a discussion that the cost of certified reference material are too much, and a number of things to be done. Is that possible for NRL to do that?
It's a big challenge because
at least in some areas, because
in some areas,
something hundreds, I mean that was something big.
At least quality control material we can think of for method validation purpose. The way people you know that this PAPAS etc. They say lots of QC material that after they organize proficiency testing the thing.
Yeah, that reference material we can quantify from accreditation body.
Yeah.
That is, we can start giving.
So at least you know that this material contains certified concentration of the compound within plus minus this much variation. So this itself is a helpful thing. So,
that we can make it as a recognized one once it gets accredited.
Yeah.
Then we continue on.
Yeah, that's possible.
The second question was that you told that analyst chemists can have a platform and then develop something on that. So is it possible that we put it in, or we accept onto that, and that becomes a proper method so that anybody and everybody can start using it?
Yeah, analytical
once
method.
You make that already you are doing it in the chapter of AOSC, but once people are there on board, and as a chemist you are coming out with some conclusion on that, can that be itself as a recognized one and people can start using that?
Hey, analytical method, what is happening for any international system? Analytical method, people are talking about that it should comply with certain criteria. And if that is criteria, then his method, my method, his method, everything is acceptable. Yeah. Only thing is that precision, accuracy, measurement, uncertainty, and all these things should be acceptable within that range. So that's very simple style these days. And of course, method should be highly accurate, and identification should be as per performance criteria. So those things are there. So with the aesthetic terms and conditions applied. So that's very important. Here, that should be in a big font.
Yes,
So
because a lot of information I could not clearly understand. I mean, not from this community, at least from
yeah, of course.
It was really very good.
See, in case of fruits and vegetables, we have already established our method through our NRL in Pune, and those methods are used by all the labs. So they are not using any international or any method from any US or a European lab. They are using all the method which we developed and we validated across the Indian laboratories. So, and the European Food and Veterinary Office people, they inspected us, they all commented so high because the results are so good and in compliance with the requirements. That's very important.
Yeah, very fine.
Thank you.
I would request Ms. Rekha Sinha, ILSI, to give a memento to Dr. Kaushik Banerjee.
Thank you.